Today is day 2 of Verilog course, and today we will discuss the most basic topic, and that is our operators. What are the operators in Verilog? And one concept is their concatenation and replication. We will see at last. This is the most important concept.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
Know the coding language like C or C++. So you know the basic operators like arithmetic operators. So let's go first to arithmetic operators. So arithmetic operator is like summation, addition, subtraction, multiplication, and all of those stuff. And the output will be stored in third variable, and you will get the answer of a, b. What is the summation of that a, b? What is the subtraction or difference between a, b? So this is our arithmetic operator. Only this much, not much. Second is our relational operator, and relational operator, as name suggests, it will give relation between a and b. For example, if a is greater or less than or equal less than, so you use this relational operator in your if else statement, conditional statements to get answer what is greater or what is less. So the output will be 1 or 0 in like a is greater than or a is less than. The answer will be 1 or 0. Yeah, yes or no kind of thing. Equality operator will check what if the two numbers are equal or not equal, which are separated in two parts, as you can see. One is logical and another is case equality. So this difference is because Verilog has two state as well as four state variables. So this logical will only check for 0 or 1, and logical 0 1, and case equality 0 1 x and z. So for example, if number is 0 1 1 x or 0 1 1 okay 1 1 1, so the case equality will give answer as 0, because it will check that yeah x is not equal to 1, but logical equality will not give a correct answer. So logical equality will only check 0 or 1. Let's move forward to our logical operator, a simple and, or, and not operator, three main gate. And logically we will check two condition. If the two condition are 1, then only give answer 2. Similar case for OR gate and your NOT gate. So these are used in our conditional operator case or any condition we are checking. So we will use logical operator. So for writing logic, you can say we are using logical operator. But bitwise operator we use for our gate level modeling, or you say data flow modeling. Will do ending of a and b. So it will do ending of a and b like 1 1 1 1, and here is 1 0 1 0 something. So it will do ending of these, and we will get some answer. Okay, so here logical we will only get answer or true or false. Here we will get the number itself. Next is reduction operator. As it suggests, we will reduce the number with the help of this operators. And or XNOR. You also see XNOR or XOR in parity checks or some files. So for example, if we have 4-bit number 1011, you say, so we are using AND, so it will AND this number and give some answer, like for example 1. So ending of this, ending of this, ending of this both, and this 4-bit number is reduced to 1-bit number. Okay, so this is a reduction operator. We are reducing the number. Next is our shift operator, and shift operator is also divided in two parts. One is logical, means we are just shifting the variable. Let's take one example, 1101. We are shifting with the, let's say 2. So either it will shift left or either it will shift right. So first we will check left. So here it will be like 0 1 0 0. As it says, logical will add 0 in the left space, and if we are shifting to right, it will be 0 0 1 1. So this is the work of the shift operator, shifting the bits by 2. Similar for our arithmetic left shift or arithmetic right shift, but it will check first the what is the bit. For example, if it is our sign number, so this one indicates it is negative. or positive. Okay, so for example we are checking negative, so this will shift this number, but it will not shift the sign. We'll check the sign. And lastly, we have our main concept is concatenation and replication. So concatenation is like adding two numbers, like here a and b are there, both are 4-bit and 4-bit. We are concatenation of these two are when we become the 8-bit number. Okay, we are just adding these two numbers side by side. It is a comma b, so it is 1010 0110. If it is b comma a, so the b will come first, 0110, then 1010. So this will be b comma a. So this is concatenation. And similar case is for replication. We are using concatenation with the help of our multiplication of this, how much time it should repeat. So it is 10, it is saying repeat 4 times. So it is repetition of 4 times of 10. We will getting 10101010. So this is for day 2. Concatenation we use most cases. We need this thing like in packed array or unpacked array. I have made video in packed array, so you can watch there. I have used concatenation while explaining this, and whatever topic you need, you can comment me. Thank you.
Please, Lord, give me a sign, a sign.